All right, lesson 49 is about linear intercepts and transversals. So, linear intercepts. So, linear intercepts has to do with graphs of lines. A linear equation is an equation that when you graph it looks like a line. And let's just go back to look at a problem we know. All right, so if I give you a graph that looks like this, for example, okay? This graph crosses the y-axis at 3. If I know where it crosses the y-axis, then when I'm writing my equation of my line, the b in my equation here is always going to be the y-intercept. So I know for that equation that b equals 3. So if I know where the point is where it crosses, I can just plug that right into the equation and I know where it crosses. So here's the question. What if I don't know where it crosses? What if it is a line and it looks maybe like this? And it's like, okay, that crosses between -2 and -3, but is it halfway? Is it a third of the way? Is it, 11/23 of the way? We don't know. So, or another example would be, what if we have a line that our picture, it doesn't even cross the axis at all? Okay. So what if our picture looks like this? And it doesn't cross the y-axis at all. Well, we can figure out where it crosses the y-axis by, it's the same process that we've been doing of finding the equation of a line. Okay? Because if we know a point where it does cross right on the grid, like right there, that's a good point right there. At that point, it's crossing exactly on my grid. All right, as I go up here, I would need to find another one. That one probably is a pretty good point. We're looking for a point where it's exactly on the grid to use to figure out the slope and to figure out the y-intercept. All right, so let's do, let me put one up here on the board. So if we had an equation like, I don't know, how about, let's make it like this. What do you think of this will work? It doesn't cross very. Let's do it like this. How about like that? I want to check one of the other points here. No. Let me change it. Let's do it like this. All right. Except that one crosses the y-axis. That's not what I wanted. Right. All right. Let's just do this. Okay. So if we want to find the equation of this line, and we don't know where it crosses the y-axis, there are two pieces of information we need to be able to find the equation of a line. We need to be able to find the slope of the line and the y-intercept. Okay? So slope is always rise over run. So the way we've done this in the past is we find 2 points where the line crosses exactly on the grid. Okay? I want to find points where it looks like it's exactly on the grid. Now, 2 of the points I see on here are this one and this one. Okay? These other points, this point isn't good because it's not exactly on the grid. It's in between 2 numbers. So we're looking for points where it's exactly on the grid. So if I use those 2 points there and I draw a triangle here to help me figure out my slope. So my rise is 1, 2, 3, 4, 5, 6, 7. My rise is 7. My run is 2. All right. So this is going down. So if I started at this point, I would have to go down 7, right 2, which means my slope would be -7 over 2. So -7 over 2x plus b. All right. Now, we have to find our y-intercept. Well, our y-intercept is not on this drawing. It's too far down here to be part of our drawing. So what we do is we take one of these points that we used for helping us find the slope. We can actually use either one of them. This point up here is the point -4, 0. That's one of the points we could use. We could use this point down here. This point is -2, -7. So in other words, we need the coordinates of one of the points that's on the line. And then we can do, we've done this before, these are xy coordinates. We take those numbers and we plug them into this equation in place of x and y. So if I use the first one, 0 equals -7/2 times -4 plus b. 0 equals, all right, -7/2 times -4 is positive 28/2, positive 14. I subtract 14 from both sides, and I get b equals -14. So I need to take that back. All right, my original equation that I was looking for two pieces. I need the slope and I need the y-intercept. So I put that back in the equation with the slope I found. My slope was -7/2x. My y-intercept, -14. And that's the equation of that line. Don't forget to put the x in there. I've noticed a few of you forget to put that x back in there in the equation. The x needs to be there for it to be an equation of a line. All right. So we really, we take our drawing, we find 2 points, draw a triangle to find our slope. Then we take one of those points, plug the x and y values back into our equation to find the value of b. And we put that back into the equation, and then we have the equation of the line. All right. The other concept is we asked about one of these on the homework about a problem with sine and cosine. Well, this is actually going to be a problem with that also. So we have a drawing like this, and we are given some information, like we're given that this hypotenuse is 7. This angle right here, we're going to call it capital P. This length here, we're going to call it A. This length, we're going to call B. This angle down here is Z. And this angle here is 153 degrees. So we're trying to find, it says here, find sides A and B. Well, this is a right triangle, so we can use, Pythagorean theorem. We could use sine, cosine, and tangent. But in order to use those, we have to know an angle. And right now, we don't know angle P. We have to figure out what degree measure that is. But one of the things we learned about lines, if these are parallel lines, which on the drawing it has, this is how you know they're parallel. They will put arrows on the lines colored in. That's telling you that the lines are parallel. The lines stay the same distance apart all the time. So that means we can use the fact that we can use supplementary angles down here first. All right, if this angle right here is 153, then what is the measure of Z? 27. Has to be 27 because Z and 153 have to add up to 180 because they make a straight line. Now if we look at this angle here, these are called corresponding angles. It's in the exact same location in reference to the parallel line as this angle. Okay? So this line is the same. It's called a transversal. These lines are exactly parallel. That means they line up. That means those two angles I just highlighted in yellow are going to be the same measure. So now we know P equals what? 27. So we can use, now we have a right triangle with a known angle and a known side, so we can use sine, cosine, and tangent to find the missing pieces. So let's use sine. Sine of 27 degrees equals opposite over hypotenuse, so b over 7. So I can cross multiply here. B equals 7 times sine of 27. Take my calculator, type in 7 times sine of 27. 7 times 3.18. I believe that most of the time on these problems they round them to 2 decimal places, I think. Except I got a different answer than the book. Why? Why'd we get a different answer than the book? Anybody know? The book says 3.15. We got 3.18. Who's right? Who's wrong? We're both right. All right, in the book, they calculated sine of 27. They've typed in their calculator sine of 27, and then they rounded it to 2 decimal places, and then used it. All right. If you just solve it like I did here, that way it doesn't get rounded until the very end of the problem. This is a more accurate answer, so I like my answer better. 3.18 is the answer you should get on that. Which I'm going to have to check to see if the ones on homework, if they did it that way on homework, because if they did, they're going to be slightly off from what they should be. So I'll check in a minute here. All right, so we also need to find B. We can find B by doing cosine. Cosine of 27 degrees equals adjacent. We need to find A, I said B. Adjacent over hypotenuse. It's the same thing, we can cross multiply. A times 1 is A. 7 times cosine of 27. Type that in our calculator. 6.24. The book had 6.23. All right. All right, you go ahead and get to work on your homework, and I'm going to check those ones on the LMS just to make sure they're correct.